Okay, what we're looking at here is a good test question. It's page 38 out of the Phillips Exeter Math 2, and it's number 10. Now what we have here is a diagram where a rectangular sheet of paper has been creased, and then corner A has been folded over to make A prime along that side CD. So, and our goal here is to find the size of angle DEA prime. So look at this angle right there. That's what we're looking for. Okay, so let's start with what we have. We are given the size of angle ABE is 30 degrees. So this angle right here, that is 30 degrees. And because we had a rectangular sheet of paper, we do know that these angles here are all 90. And I'll make this a different color. So we're trying to find this red angle right there. Okay, now since these two triangles, since this was folded over from here to here, those two triangles are congruent because that triangle A prime EB was at triangle AEB. So that means that this angle down here, right here, would be 30 degrees. Let's go ahead and put that there. We can also know that since we have the triangle ABE that has to add to 180, and this angle right here, angle A, is 90, we can go 180 minus 90, which is 90, and we know that this angle right here, that has to be 90 minus 30, which means that this is 60. 60 degrees there. Because that's 60 degrees and these two triangles are congruent, this angle right here is also 60 degrees, which means now this red angle is pretty easy to find. These three angles need to add up to 180. So we would go 180 minus 60 minus 60, which gives us 60. So this angle we had to find, DEA prime, is 60 degrees. Okay, now let's look at B. What if that angle didn't start out as 30 but started out as 27? Okay, now we have that this angle here is 27, so we can follow the same idea as we did before. We have that's 27, which means this is also 27. I'm not sure if we really needed it to find this angle. This angle right here would have to be 180 minus 90. So 180 minus 90 minus 27. I'll go ahead and write that. That'd be 90 minus 27, which is a 63. So this right here is 63 degrees. These two triangles again are congruent. So these two triangles are congruent, so therefore this angle is also 63. And then we can do the same thing we just did of 180 minus two 63s. So minus 63 minus 63. So we do that, and that should be a 54. So then we get this angle up here is 54. Now when we had 30 here, hopefully we're starting to look at a pattern here. When we had that this was 30, we got that this was 60. And now that we see that it is 27, it is 54. So let's look at n degrees now on C. Should start seeing a pattern. Okay, the last one we have here is n for angle ABE. So we can follow the same methods we did before. To get this angle right here, we did 180 for the triangle minus 90 minus the n angle. So that angle right there would be 90 minus n. Okay, and since these two angles were congruent because of the congruent triangles, that means that we also have another 90 minus n for that angle. And then lastly, to finish it off, to find the angle we wanted, which angle DEA prime, we had to go 180 minus 90 minus n for this angle right here, and then minus another 90 minus n for that angle, making sure that we have that 90 minus n in parentheses because that's the whole angle here. And that would be measurement of angle DEA prime. We do a little simplifying here. That would be 180 minus 90 plus n minus 90 plus n. And then 180 minus 90 minus 90 is just 0. So our final answer is 2n. And that would be angle DEA.